Our guest today is Raluca Ada Popa. Raluca is one of the world-leading researchers in computer security, systems, and applied cryptography, areas that are becoming more and more relevant to artificial intelligence. After completing her undergraduate and PhD at MIT, she did a postdoc at ETH Zurich and became professor at Berkeley, where she still is today. In addition to being professor at Berkeley, she has founded 2 startups. First, PreVeil, which provides simple encrypted document collaboration and email, and then Opaque Systems, which enables confidential computing for collaborative analytics and artificial intelligence. Raluca has won numerous awards. Among others, she won the George M. Sprouse Award for Best Dissertation in Computer Science at MIT. She won the MIT Technology Review 35 Innovators Under 35. She won the Sloan Fellowship. She won the ACM Grace Murray Hopper Award. Raluca, before diving into today's conversation, I'd like to thank our podcast sponsors, Index Ventures and Weights and Biases. Index Ventures is a venture capital firm that invests in exceptional entrepreneurs across all stages, from seed to IPO. With offices in San Francisco, New York, and London, the firm backs founders across a variety of verticals, including artificial intelligence, SaaS, fintech, security, gaming, and consumer. On a personal note, Index is an investor in Covariant, and I couldn't recommend them any higher. Weights and Biases is an ML ops platform that helps you train better models faster with experiment tracking, model and data set versioning, and model management. They are used by OpenAI, NVIDIA, and almost every lab releasing a large model. In fact, many, if not all, of my students at Berkeley and colleagues at Covariant are big users of Weights and Biases. Raluca, so great to have you here. Welcome to the show.
Thank you, Peter. Thank you very much. Excited to be here.
Well, thank you for making the time. Now, artificial intelligence and security are getting closer and closer together, especially because AI in recent years has become so much more capable and more relevant, and hence security becomes important. One of the big things with modern AI is how much it relies on data. And there's this apparent kind of tension between maybe people wanting to keep their data private, yet to train really capable AIs, you need access to a lot of data. Is there a real tension there? Is there a solution to this?
Absolutely. So on the surface, there's a tension, as you said, because you're trying to keep the data private, yet learn from it. But we have some amazing technology these days called confidential computing, which enables keeping the data private, essentially encrypted. You can think of it as, garbage jumbled up, but then still being able to run training algorithms and prediction while keeping the data encrypted. And the nice thing about that is you can, for example, train your algorithm in the cloud without concern of what cloud employees or hackers into the cloud see. But also, actually, I think this is very important, is actually makes it easier to collaborate. Let's say, 2 hospitals don't want to share their confidential data with each other, but they want to train to obtain a better disease treatment or diagnosis for a disease if they put their data together. So like this, with confidential computing, they know that their data is going to not be visible to anybody. It's going to stay protected, encrypted, but still be able to run their machine learning. So it really enables this kind of collaboration and hence building better AI models.
I love this healthcare example. I think most people at least I know, find their healthcare data sensitive and don't want it to just be out there, but also want to contribute to discoveries of new treatments, cures, and so forth. Are there other application domains where you see this confidential aspect to be really important?
Absolutely, yes. So definitely in the financial services, we see a lot of it because banks want to catch money launderers, for example. these money launderers hide their traces across different banks. For example, do transactions in like a transaction loop. And if you look at any one bank's data, it looks like there's no fraud. But the moment you put different banks' data together, you start seeing these loops and quite easily, many times, identify these money launderers. But the banks won't share data with each other. They're in competition or there's regulations. They can't just show each other the customer data. So we're working with them on exactly this application where they are using confidential computing and leveraging its power to enable them to share data and be able to catch the money launderers much more efficiently, but without showing the data to each other.
So this all sounds pretty magical to me.
Yes.
The idea that the data stays private, is not really shared, stays encrypted, yet somehow you compute something from the combination of the data that is a more interesting statistic or a more interesting piece of information, or maybe weights in a neural network that get updated. Technology-wise, how can this be done?
Yeah, great question. And I remember when I was an undergrad at MIT and I first started doing research, I was also fascinated by this. I liked how it seemed impossible. It really does sound magical, right? But it really is possible through the power of math and hardware. So initially what we had is some encryption algorithms that have special properties that enable computation. So for example, the encryption of some data could have a mathematical structure that if you multiply two encryptions, you get the encryption of the sum of the values. And this is just because of the mathematical properties. And like some, you can do more operations and eventually you can run entire programs. But this is really, really beautiful science, and I've done a lot of research on it myself. It's practical in some cases. For example, you can do simple prediction, maybe simple training of linear models. But if you want to do much more complex training, like deep neural networks, then you need much more performance for that. And this kind of cryptography is still very slow as of today. But the exciting thing is that recent hardware mechanisms have created an alternative that's actually very, very, very efficient. So these are called enclaves. And a lot of cloud providers these days offer them as a service, so you don't even need to acquire specialized hardware. But what they do is, think of an enclave, right? What comes to mind? Well, it's the idea that your data is closed in to a silo where nobody can see it. And this is what the hardware creates. Basically, your data stays in that hardware silo, and whenever it goes out, it's in encrypted form. And now servers in the cloud have these enclaves. So what's super powerful about this is that whoever looks in those servers, even a hacker breaking in, or the system administrator or the operating system itself, they only see encrypted data. Because whatever comes out of this silo, which has a seal on it, it's encrypted. In memory, it's encrypted. On the memory bus, it's encrypted. Only deep down in the metal, it gets decrypted, but nobody gets to see there. But because it gets decrypted in the metal, computation happens normally. So here we are having really fast performance for basically close to native execution. But then for anybody looking in these servers, hackers breaking in, they only see encrypted data going in this enclave silo, encrypted data going out, encrypted data in, encrypted data out. So it looks like it's just manipulating encrypted data that the attacker cannot decipher. So it's extremely powerful. You can both compute and protect the data, kind of have your cake and, eat it too.
That's amazing. Now, let's say we make this concrete for neural network training. Let's say I want to train a neural network, and maybe there is 2 hospitals that have data in 2 separate enclaves, and maybe I want to be the one training the neural network. Can you break it down? How do I go about that, and what happens to the data in the process? And where does the neural network live?
Absolutely. So there's many different ways where you could deploy that. You could deploy it in a decentralized manner at the hospitals, but I'm going to tell you a very simple one that's based on the cloud. So you are Peter and you show up at this hospital A and B, and say, look, if I run this neural network on your data, I'm going to get, this model that's going to be really effective at, curing cancer. So the hospitals are going to say, great, Peter, we want you to run this model. So what they're going to do is they're going to encrypt their data and put it in these enclaves on the cloud. Now, the really nice thing is that enclaves have a way to check what's running inside them. So the hospitals can really make sure it's Peter's deep learning network that's running and nothing else, not like extra malware, nothing scary. It's just Peter's algorithm and nothing else. Now, Peter's algorithm is going to run on this data in the enclaves. Only the enclaves have the ability to decrypt this data deep down in the metal, run the training process, and output some model. So now you have two choices. The model can be sent to you, Peter, in encrypted form, or the model can be kept in the enclaves, so not even you get it. Okay, if it's kept in the enclaves, then you can have patients show up and say, here's my medical data, please tell me what's the best cancer treatment for me to this model. So again, they would upload their medical profile information and the model would predict and produce, encrypted results that only the patient could decrypt and access. So basically the idea is that nobody gets to see the data. None of the hospitals gets to see each other's data. You, Peter, don't get to see their data, but you get to run your algorithm and train it, your neural network algorithm, you get to train it on the data of these hospitals. And then patients can enjoy predictions from that algorithm on their medical data. But again, nobody gets to see their medical profile either.
That seems maybe the most safe version. What if I want to get the neural network out and maybe I want to run things on that neural network myself?
Yeah, absolutely. So in that case, of course, the hospitals would have to had agreed with that procedure. There's simple policies they can set and say, once the training is done, the result can be sent to Peter. The model can be sent to Peter. In that case, the enclaves in the cloud will encrypt the model and send it encrypted to you, but they'll encrypt it with a key that you get to decrypt. It's your key. So now you have the model and you can play with it. You haven't gotten anything else about the data of the hospitals. You only got the model, nothing else. But of course, the model itself could still remember some information about the data. And we've seen cases where models remember too much. And there you can actually use some other techniques we have in security, things like differential privacy, which try to make sure that the model you receive doesn't retain any information about any particular individual whose data might have been in those hospital data sets. But it still keeps accuracy of the overall model.
So this differential privacy aspect is really intriguing to me because you're saying that even though the model was trained privately on the data was never exposed to me for me to do that training. It could be that if I'm not careful about how I run the training, or the hospital is not careful about which algorithm I use for the training, then my neural network will actually have the data in it, or some of the data in it, and I could, well, if it were a language model, maybe just prompt it with something, and then it would just spit back out some of the training data, maybe.
Yeah, that's a very good point. So what could happen in that case is a few things. So the hospitals can enforce a policy saying that, they could obviously check the script, and if they have expertise, they can just really say, yeah, we like this training script, it's okay. But that's maybe too sophisticated for some hospitals. Others, what they could do is they could say, well, whatever comes out of that's sent to Peter can only be at most, 100 kilobytes. And that limits the amount of information that can be sent. For example, if they each put in a terabyte of data, 100 kilobytes is just not going to be able to carry that much information about the data in the database, although it could record one specific person's data. And the third one, which is more sophisticated, is they could force differential privacy to be added to your model so that in the training process, your model cannot remember specific information about any specific user. And you can do that for a number of scripts efficiently. For others, it's a bit less efficient. But this would be, for example, 3 options. The point is that the core of all of these options is that the hospitals control what gets run on their data and what gets released, and they get to make the decision, and you cannot, squeeze out more than what they have controlled and allowed to.
I'm curious, during the training, let's say I train across multiple hospital databases that are each presumably living in their own enclave. Does my neural network need to then hop around between them? Or I guess, how is it going to train across those multiple enclaves?
Yeah, that's a very good point. So in this case, actually, it's really safe to load the hospital's data in the same enclaves in the cloud. So you don't have to hop around. Both hospitals are going to load encrypted data there, and only that enclave can decrypt it in the metal itself. But outside of the enclave, it's always going to be encrypted to anybody looking upon the enclave, to a hacker, to the operating system, to cloud employees. It looks encrypted. But the point is that this hardware it's something that it's essentially like common ground that both banks can upload their data to, because nobody controls it. The important point here is that both hospitals get to set up that enclave at the same time. So what you do is, let's say one of them goes ahead and sets it up. It's running Peter's script and their policies, and the other one gets to check. You can check what's running in that enclave. Why? There's this really cool feature called remote attestation, where the enclave measures itself. And this is in hardware. This is done in hardware. So the enclave takes a hash of its entire code and then sends this hash to the 2 hospitals. Now, this hash is like a checksum. It's like, if anything runs in the enclave, then what they expect, the hash will match. The nice thing is that this hash has a seal on it. We call it a signature in cryptography. From who? From the cloud provider, let's say Azure, saying, yes, this is a valid enclave server in my cloud. And from Intel saying, for example, this is a legitimate enclave by me, Intel. So it has the seals of being a legitimate enclave running in the correct cloud and measures exactly what's running. So that's why both of the banks can make sure that this enclave is really going to run what they want it to run and nothing else. And it's a safe place to put their data because nobody's going to see it.
It is really cool. We've talked about the bank use cases, hospital use cases. Are there others that you see emerging?
Yes, absolutely. So actually, a popular one that we're having a bunch of success with right now at my company, Opaque, is ad tech. So in ad tech, cookies are going away. And a lot of ad tech providers are extremely worried because they used to create ads based on cookies and based on user information. So right now, what they need to do is they need to obtain data sets from different partners. They need to obtain more user information and to process more user information. And we're seeing situations where an ad tech company would obtain some data set from another company if they could not see it, right? So another company is happy to share data set for some training, for some analytics, but they're not willing to actually show the entire data set. So with confidential computing, we found that it's easier to acquire data sets because parties are more willing to give them because they know they're not going to be viewed, they're not going to be visible, and only some model out of them or some summary or some statistics will come out of them. So that's, I would say, a really popular use for it right now.
So just to be very explicit here, this confidential computing is not just something you're doing academic research on at Berkeley. You also have a company called Opaque Systems, which is actually commercializing this. And this is something that's happening today, has been happening for a little while now. Can you take me back to when did you decide to start Opaque? And what's the story there and where are you now?
Yeah, absolutely. So exactly as you say, we've done a bunch of research in confidential computing, but it's not just research, a paper in the shelf. It's actually a real product you can use in Opaque. And so the story of that is that in the RISE lab at UC Berkeley, my co-founder, Leon Stoika, and I, and 3 of our students who are now co-founders at Opaque, we were doing a lot of research and building open source, which is called MC2, so multi-party confidential computing. And basically, we were collaborating with industry, with banks, actually hospitals, the big tech. And they were giving us really useful feedback. But one of the feedback was, wow, I really like this. I want to use it. They were using internally or trying it out in production, but I need 24/7 support. I need graphical user interface. So I need features that you don't do in research. They're not rewarded in research. So it was very obvious that there's a need for, making a real company on this that has a product that's very, very easy to use. And I'd say that, we had a big advantage in our research because we received these new hardware capabilities, these enclaves, from Intel just years before they were commercially available because they were a collaborator in our lab. And, having them a few years ahead, we could build our open source, we could do our research, and really gave us a head start even commercially. So that's basically, it was super organic and natural. I remember Jon and I, Jon Stoik, as I mentioned, is my colleague at UC Berkeley. He is also co-founder of Databricks. So Jon and I were, having a meeting with the students who were leading the open source and the research. And, super naturally, both parties proposed the idea of, a startup to the other. The students had graduated or were really about to graduate. So it happened very, very organically.
And when was it founded?
Yeah, the company was founded 2 years ago.
2 years ago.
Yeah.
And so is this the first company in this space, you think?
Very good point. So in the confidential computing space at large, there's actually a few other companies. Fortanix was one of the early ones. They have a very different focus. They focus on using enclaves for key management, replacing, for example, HSMs of AWS. But our focus is on data analytics, machine learning, analyzing confidential data, extracting value out of it, no longer having it locked down and, unusable and reachable. So we have a very different focus. And I'd say that within this focus, to the best of my knowledge, we really are the first. And we're also the premier group, team that has done research in this space and has pushed the envelope in this space. I do want to add that since we started 2 years ago, this whole space has gotten so hot, and there's a bunch of other companies and startups all getting good funding, and it's a really hot topic. And that, I think, is the confirmation of this community and of this direction. And that's really exciting.
It is really exciting to be at the beginning of this whole emerging new space. Now, one of the things you mentioned, you co-founded the company with Jon Stoik, one of our colleagues, right? One of the co-founders and co-founding CEO, actually, of Databricks, one of the biggest startups ever. I think currently $50 billion valuation, something. I'm really curious, as you start the company with somebody like that who's gone all the way from starting to one of the highest value startups in the world, are there some lessons you learned along the way that are interesting to share?
Yeah, absolutely. I mean, it's definitely an honor to be able to collaborate with Jon, not just on research, but on the startup. And definitely, I've been learning a lot from him and our co-founders and the rest of the company. We've really been learning a lot from him. Lessons, I think, one of the really interesting things I learned from Jon is the open source model. In our lab, and also Databricks had the same story. It was, they built the Spark as open source, and then that open source became very popular, had a large community, and then they built a company around open source. And we have a very similar model at Opaque. MC2, our open source, is freely available. Anybody can use it. It has a permissive license. We're still contributing to it. But then the company Opaque provides tools around it for enterprise, ease of use, enterprise integration. And what I learned from Jon is that, this model works incredibly well. And it's honestly not intuitive initially when you think about it, because you say, wait a minute, the core of your platform is open source. Then what's the company's IP? What's the company selling, right? It's really not obvious on the first sight. But then when you look at it closely, it's a really nice model. First, with open source, you build thought leadership. people get to try it, build confidence in it, especially if it's a disruptive technology. They need to play with it and build confidence. People don't necessarily feel tied to a company if they don't want to be. So you really build that trust and thought leadership with open source. And then many companies would still want to use tools that make it easy to use, tools that integrate with their enterprise, ecosystem. They'll still want to have the 24/7 support, somebody to call if something doesn't go well. They'll still want to, not have to deal with updates and maintaining this. So it's actually very natural that they still need the company's product. So you can really kind of get the both of, the two worlds, thought leadership and, the ease of use and the company product.
And talking about prior startup experience, Opaque is not your own first startup. You already did another startup before called PreVeil.
Yes.
Can you say a little bit about that?
Yes, absolutely. So I think PreVeil now is a company. I wouldn't think of it as a startup anymore. I started it at the end of my MIT PhD, before I started UC Berkeley, which was definitely crazy, but it felt like it was really solving a big problem then, and it was the time for it. So what PreVeil does is it enables email and file sharing, encryption, but also compliance with some of the most stringent regulations, like in the defense sector, CMMC, ITAR. And so we have very, very strong level of security through something called end-to-end encryption. Basically, not even the servers have the keys to decrypt or access the files. And it's really targeted to enterprises. So it integrates really well into the softwares that enterprise has, into the typical tools that they have. And importantly, it achieves compliance. A lot of, for example, companies in the defense sector or contractors working with the defense sector, they have extremely stringent regulations that it's a pain to comply with. But with a technology like PreVeil, you can just, in a matter of half an hour, set up in your company this technology and be compliant with extremely difficult regulations. So right now we have more than 500 companies that are using PreVeil, enterprises, and they have, some of them have thousands of users, others have fewer for mission critical tasks, and we're actually a big vendor in the defense sector for cybersecurity protection and compliance.
This is really amazing, Raluca. I'm curious, can you give a little bit of an intuition? What is kind of the secret, maybe not the secret sauce, but kind of the high level intuition of the PreVeil technology that allows it to do things that a regular email server, a regular document sharing server wouldn't be doing?
Yeah, absolutely. So it's something called encryption in use, or end-to-end encryption. The idea is that even the server itself doesn't have access to the data. The data is encrypted, but the key for the encryption is not at the server. It's at the users. For example, on my phone, I have the key to decrypt my emails or my files. But I don't have the key to decrypt anybody else's emails or files. And the server itself doesn't have the key to decrypt the files. And as you know, a lot of hacking attacks happen to servers. So now, for example, if a server were to break into Gmail today, they would get a lot of emails. They would get the emails of everybody using Gmail. But if an attacker breaks into a PreVeil server, they get encrypted emails. They're garbage. They don't get to see their contents. And because of this, it's much, much easier to comply. There's a ton of controls and things you have to do on a server where the data is accessible. Like a Gmail server, for example, the Microsoft GovCloud is also a mess to set up for this purpose, but you can. Because if the data is accessible on those servers, you have to do a lot of things to protect it. But if the data is not accessible, even if an attacker breaks in, it's in encrypted form, then there's much less hurdles that you have to go through to be compliant. So it becomes much easier for a company to be compliant with the use of technology than traditional technology.
Well, that model seems dramatically safer, intuitively speaking, but it seems like there could be a downside in the sense that if I'm decrypting on my phone, let's say, with my key on my phone, what if I lose my phone? Is just nobody can get to it anymore?
Yeah, that's a very, very good question. Very good question. So actually, you're really getting at the heart of this. The idea of encrypting and just having the users decrypt was there for a while. But the precise reason why it wasn't deployed is issues like that you mentioned, usability. And because we solved those, that's why we could actually deploy a solution like this. So in your example, there's something that we have, basically we call it approval groups. What happens is, let's say, Peter, you work for a defense company. When you create an account and you generate a key, the key gets sharded. What does it mean? It gets split in pieces. And some piece goes to your boss, another piece goes to the HR department, another piece goes to some other admin. All behind the scenes, you as a user don't have to worry about any of this. And the cool thing is that, let's say your boss, with the piece that he gets, the shard, they won't be able to decrypt your data. In fact, 2 out of 3 of those people have to come together, or 4 out of 6, or whatever policy the enterprise wants. They would have to come together and reconstruct your key. So this is really helpful because if you lose your device, you just call up your boss or an admin or HR, and they can reconstruct the key and you regain access to the data. But if one of them goes wrong or an attacker hacks one of them, like an admin, attackers have hacked so many admins, they're not the central point of attack. They can't get to your data.
And going off of this a bit more, I like this solution a lot, the sharded key and having people help you get your key back. But now what if I lose my phone? And sure, I'd like to get my key back, but at the same time, maybe somebody who is malicious found my phone and is going to be able to access my data online. How to also prevent them? Because they have the key at that point.
Yeah, very, very good point. So we have something called the red button, which is basically a situation where you lost your phone and you think somebody accessed it. Then you basically, again, call up your approval group, your admin, your HR, your boss, and explain to them the situation. And let's say this company set up that if 3 out of 4 of them said, delete that key and rekey, then that's going to happen. So it all depends on, of course, what policy your company said. It could be 3 out of 4, 3 out of 5, could be 2 out of 3, whatever they consider safe. But basically in that situation, this approval group, they could invalidate that key and trigger a new key to be created on your new phone and your data being re-encrypted with that new key. So it gets decrypted with the old key, re-encrypted with the new key, and then the old key invalidated.
Got it. So there's this brief moment where it stays encrypted with the old key, and you need to very quickly, essentially, decrypt, re-encrypt, and you're good to go.
Yes. And that moment is, crucial because it's all about who are you, right? Are you the right person or not, right? And if you have your phone, you access your data, it's just part of your basic functionality. And in that moment, you give it to somebody else willingly, right? Or you lose it for some time. Who really is you, right? So for that interval until you decide to cancel things and that you lost your phone, it could be that the attacker gets your data and downloads as much of it as possible. But as soon as you kind of realize that this is the case, you can stop it.
Seems like in practice, it wouldn't happen very often, but just from a kind of pure research point of view, it seems like there's an interesting research question there. If the data has been encrypted already and I want to rekey it to a new encryption, can I do that without ever decrypting it? Just like it stays encrypted and it becomes re-encrypted against a new key without ever having been opened up.
Yes, you can. You absolutely can. And it's a concept called proxy re-encryption. Basically what happens is that you can just provide to the cloud or wherever your data is stored encrypted, a delta. It's like a delta between the old key and the new key. And then with that delta, the cloud can apply the delta on the old data and get an encryption with the new key. So that's possible. It's not the most efficient, and unless you want to go there, it's not necessarily always the best approach, but it's possible, and it's a nice concept.
That's so interesting that's possible. Very intriguing to me.
Yes.
Now, Raluca, I'm curious. As you know, I've always been working in AI, not nearly as much in security at all, but the two fields are getting closer together, and you are working with a foot in both. And I'm really curious, what do you think will happen in the next 5 to 10 years at the junction of AI and security?
Absolutely. I think that for people to train models on confidential data, my prediction is that they would have to employ confidential computing. Both to keep the data private, also to acquire data sets that otherwise would not be shared. Basically protected during the training phase. I think that's a really big one. And actually, Gartner has an interesting survey saying that basically by 2025, 50% organizations that are doing some sort of analysis on data will be using confidential computing. So I'd say that's a really big point. It's basically securing the data during the training process, because the training process many times accesses so much confidential data. It's like a really juicy target for attackers. And securing the data during that process so nobody gets to see it is a very important area of, I think, where the confluence, where they're going to come together. Another area that's not entirely fully solved is how to make sure a model doesn't remember too much about either an individual or doesn't learn other information that's not supposed to learn. And not all of that is solved. I mean, differential privacy partially solves, as I mentioned, the making sure that the model does not retain information about a specific user. But learning something and not learning something else in the process is still not fully solved.
Those are two really important directions. I'm actually curious. You've mentioned differential privacy a couple times, and I'm curious, what's the intuition? How can an algorithm decide to not retain too much about a specific user? What do you do? Let's say we start from a regular neural net training process. What do we change in the process to ensure that it still learns yet doesn't retain too much specifics?
Yeah, great question. So maybe I'll start with an even simpler example first. So let's say you want to compute the average salary of users in a database. And you don't want from that average to kind of learn whether Alice was in the database or not, or whether she, has a ridiculously high salary or very, low salary. You just don't want to learn anything about any specific individual. So what differential privacy does is it adds some noise to the average. You compute the actual average and you add some noise. And the noise is added based on some things like, let's say, Gaussian noise, but it's added based on some mathematical algorithm that proves that given a noisy result, the chance that Alice was in the database or not, it's very similar. So basically, you cannot distinguish the probability of whether she was in the database or not from that noisy result. At the same time, the idea is that the noise does not affect accuracy a lot. It just changes a little bit the accuracy. Mm-hmm. But this is only, the accuracy is going to be good and the error is going to be small only if it's a larger data set, right? If it's just two people and there's Alice and Bob in a data set, then your average is going to have a lot of error so that you can hide whether Alice was in the database or not. But if it's a really large data set, then your average would have much less error because it was easier to hide whether any specific user was in the data set or not. And there's basically mathematical algorithms that tell you how much error to get to have those two probabilities of Alice being in the data set or not very close. And now, going to neural networks, basically what happens is you similarly trace the function that gets computed and keep adding error either at every stage or at the end, depending on the algorithm, so that provably the result, is the probability that Alice was in the data set or not, or any other user, are very, very close to each other, whether the user was or not in the data set. But of course, how the algorithm works, it's a bunch of math. It's kind of hard to explain, but that's basically the intuition. You just add noise by looking through the function that you're computing and seeing, okay, what is kind of the minimum and maximum if any one user were or were not in a database. It's kind of called the sensitivity. And trying to kind of have your noise similar to that sensitivity so you get to hide it. That's just some intuition.
It's very interesting. I mean, I'm thinking about neural net training. I'm thinking when something is in the data, is going to run a forward pass, backward pass over that. There's going to be a gradient based on that says in which directions the parameters should change. And you're saying that there's essentially a way to put the right amount of noise on that gradient update such that, of course, based on other data and maybe looking at the other gradients such that this one update cannot retain too much information of the original data while still passing some signal along.
Basically, yeah. Basically, you have the data set and you think of, you treat your learning like a function, the deep learning neural training algorithm like a function. And there's something called sensitivity. So how much can this function result vary if any one user is or is not in the data set? What are kind of the bounds that this result would vary between? And you add some noise that is based on that amount so that the noise kind of messes the result within that kind of interval of what any one sample can offer, can kind of affect. This is just some intuition. Mm-hmm. And of course, if the result is highly sensitive based on any specific user, you get to add a lot of error. So for example, if I make a query where I really want to know Peter's salary, it's going to be completely jumbled result because, the sensitivity is between, 0 or maximum, right? What could be your salary? But if I issue like an average on 1 million records, then how much any specific sample can affect the result is very small, and hence the noise will be very small. And a similar reasoning applies to the neural network algorithm. You basically need some bounds as to how much any one sample in your data set can affect the model results, and then add commensurate noise. But of course, it becomes much more complex for this function.
Right.
And it's provable. It's provably the case. So it's not a heuristic here. You can really prove that you cannot figure out if any one user was or not in the data set with more than a very small, very, very small probability, close to zero. Close to zero, 1/2, like guessing randomly, really.
That's a beautiful field and results there. Now, switching gears a little bit, I'm curious, you grew up in Romania.
Yes.
So I'm curious, you started there. What kept you busy as a little kid, and how did you get into computer science?
Yeah. So in Romania, I really had fun with the Olympiads. So I would participate in Olympiads in math, physics, and computer science. Basically, for computer science, it was like ACM programming contests. But you start, at the high school, and the best one from the high school, based on, you take a test that's, supposed to be much more challenging than your average, school exams. The best one goes to the school, to the county level. First town, then county level, then region and country. And it becomes harder and harder because you compete more and more, and usually just the best from each level goes to the next one. And so I was really having a lot of fun with those Olympiads in physics, math, and computer science. And so that definitely got me, I was generally always very interested in engineering and science. But then I think I just always saw computer science as something of the future that can really change our lives, and you can have a ton of impact, and it's really, really fun. Even though at the high school level, my biggest love was physics, so computer science was kind of number 2. I was really having the most fun problem solving in physics. And so I remember there was this year when I finished first in the county in all the 3 Olympiads, and I had to choose one to go to the national level, and I chose physics. But I knew that I loved computer science a lot too. Just for the Olympiads, I just loved the intuition of guessing, the phenomenon of what's happening. I love the problem solving there, but I didn't really want a life in a lab, doing a lot of experiments that take a really long time, or doing theoretical physics where you cannot do many experiments. I really liked how with computer science, you can actually, the everyday life of computer science, I liked it much, much more. So I ended up pursuing that. Coincidentally, my mom is also a software engineer, which in communist Romania is super rare. Very, very rare to have a woman do that. And I would see her in the evenings just coding. Actually should have some red wine and code. It was her favorite, Zen moment. But I wouldn't say that I do computer science because of her. Normally you hear the stories, oh, my mom inspired me. No, it's not her. Partly because I would ask her, Mom, what are you doing? And she'd say, oh, leave me alone. I'm focused now. If you will like this later, you will do it. That, you'll discover on your own. Right now, leave me alone. So it's not that stories where the mom inspires me. It's more like probably we had very similar inclinations.
Now, it's so interesting you say that because I'm very curious when you say you had similar inclinations. Are there any moments when you're maybe really young, well before high school, that you think kind of stand out, and maybe activities you were exposed to at home, at school, or anywhere else that kind of maybe somehow let you learn that this was your natural interest?
Yeah, it's interesting. I definitely think that my mom always encouraged us to reason logically. And we'd hear someone said something, or someone thinks something, and she'd say, what do you think yourself? Think logically. Ignore what they're saying. What is your mind telling you? So just always encouraging us to think logically. Also, she wouldn't like us memorizing many things. She just like us say, memorize the minimum possible, just derive and think logically. So I think that I think that definitely influenced me a lot. And also in the early days of primary school, I remember when I would have some struggle with something I didn't quite know how to do, some piece of a homework or something, and she gave me a bit of help. But the help was in such interesting way and was so interesting how she was thinking of the problem, and she was so fascinated by it, and she had so much fun. And she showed me the beautiful parts of that reasoning. And even though, besides those early years, she never really helped me with homework anymore or anything like that, I think it did make a big difference in how I thought about reasoning and how I enjoyed it and how I could see the beauty in it. So I do think in that sense, she had some influence on me liking engineering and science very, very indirectly.
Have you adopted the habit of kind of coding while drinking red wine?
No, actually, I don't think it would work very well for me. I don't think I would. I don't think I would have such high quality of my code. I don't think it's for everyone.
Well, I think it's definitely not for everyone. That's for sure. Now, you're so young, yet you've already achieved so much, more than pretty much anyone will achieve in their lifetimes. Yet you're still going very hard, if anything, maybe even harder than the year before, What drives you on a day-to-day basis? What gets you excited to push so hard every day?
Interesting. I think it's just a lot of fun. I think I get excited about research problems with my students. We're very lucky and privileged to have extremely smart students. And so we just get really excited and have really fun doing the research. And we see these beautiful problems and solutions ahead of us, and we want to grasp that and that and that and that, and we want to, solve all of them, and not really thinking of how much time there is in a day. And besides that, on the company side, is really wanting to not just have those papers sit on a shelf, but having them actually change the world, having them actually be used. I'm a strong believer that if you really want to change the world, it's not enough to publish the algorithm and the how in a paper. You have to go and really do it and show it. And nobody's going to care about some work as much as you care about your work and about, understanding its potential and, going through the hurdles of making it super easy to use, of having the right messaging, of educating people about it. So I think that kind of impact really, really excites me. And actually in confidential computing, it's, when I wake up in the morning, it really motivates me, the fact that I know that it can enable collaborating with sensitive data, medical, financial, things that are not possible today. For example, cancer treatment suffers enormously from the fact that hospitals cannot put their data together. It has been shown that with more data, you get better treatments for cancer. So that really motivates me. Okay, if I can unlock, the potential of this confidential data and enable better medical treatments, or you can catch money launderers, or actually human trafficking also. It's primarily caught through financial forensics. And that really motivates me that, my research can help society in those ways as well.
Really inspiring. You mentioned part of what you do, of course, is working very closely with students.
Yes.
And every year, many, many students apply to come and work with you. What do you look for when recruiting students?
That's a good question. I look for, obviously, a match in terms of interests, but really I look at their prior experience, how, the work, the research they've done so far. I look at their letters. I look at, what faculty I know and trust have experienced while working with the students. And ultimately what I want to gauge is obviously intelligence, but there's many intelligent students. I want to gauge this proactivity, this desire to, change things, to push for things, to own something and create. So the drive and the creativity of solutions. So it's definitely a very complex question, but work ethic and intelligence are really just one part of it. And at UC Berkeley, we have many applicants that have it. I would say it's also this desire to kind of have initiative and independent thinker and proactive and pushing for things they believe in. That I find that really leads to a very successful researcher.
Often people think of people are smart or more smart, less smart. It's almost a bit like a given, like this person's smarter, that person a little less smart, and so forth. Obviously, it's also a muscle that we train, and you can really build it up, become. I don't know if you intrinsically become smarter, but you become, in practice, smarter in many ways. And I'm curious, generalizing that a little bit also towards the creativity that you referenced. If, let's say, much younger students that are not applying yet right now, but maybe are still in high school, are hoping to pursue a very successful career in security, junction of AI and security, what are some of the things that they could be doing to kind of shape their own thinking?
Yeah, good point. I think that if a high school student is interested in this, obviously, trying to pursue a college where computer science is a degree that they care about and they invest in, and it's a strong degree, and that they offer computer security classes. It's a very pragmatic thing, but, they need to acquire some, knowledge. They need to acquire some, experience playing with it. So I'd say this is really number one. And then in this process, they're going to discover if they really like it or not. And also they are going to get indirectly evaluated, right? What research they managed to do, what courses they managed to take, how do they perform? So yeah, I would say the pragmatics education is still very, very important to a career in security and a future in security.
Now, for students who are already at Berkeley, you actually put together a new program a couple of years ago called DARE, and I've recruited students from that program that you put together, really, really good students. What is the DARE program, and what motivated you to put that together?
Yeah, so there is a program for enabling undergraduate researchers from all walks of life, all backgrounds, underrepresented or not, to find research opportunities. So we found that many students, even if very smart and very strong, they tend to be intimidated by faculty and, how do they find the research opportunity? Sometimes they didn't even consider that they can find it, and they just instantly go for an industry internship without even trying research. And we also find that students from underrepresented groups, unfortunately, many times are daunted by this process of finding a research match with a professor. Professors are much fewer than students, especially at Berkeley, where we have a huge major, and it's really hard to reach. So basically what the DARE program aims to do is to kind of remove this, daunting part of the process and have the faculty and the grad students reach out to the students instead. The student simply applies, they send a very simple application because much of the application is pulled out automatically from the campus system. And then grad students and faculty can look at student profiles. We facilitate that process by also showing more relevant applications based on faculty criteria. And then the nice thing is that the faculty and the grad students reach out to the student. So there isn't anymore that phase where the student is intimidated. How do they reach out to the faculty? How do they approach the faculty? They're daunted. They're just being reached out to by the faculty or the grad students. And so we found that, many students, actually even a lot of minority students have told us that, thank you so much. I didn't even know where to start. I was intimidated. And now I have a faculty asking me to do research with them. And, research has been great. And so that's basically the thinking, was really trying to solve a bottleneck in this process of engaging students from all backgrounds to do research.
Definitely worked well for me and my undergrad researcher recruiting. So thank you for putting it together, Raluca.
Glad to hear. And these days I hear that actually my students who went on to become professors, like Wenting at CMU, are looking into implementing a similar program there. So that's really exciting.
Yeah, that's what I was wondering. If how easy or hard would it be to transfer it to other schools?
I mean, theoretically, it should be pretty easy within ECS because at least at the peering universities, we work, similarly in concept, the way we do research, in what we value in an undergrad researcher. But of course, there has to be also willingness of the administration to embed this, the web system we built, the backend, into their campus system, because that makes everything so much easier.
And making it easier is a big deal because, yes. Students are already afraid to approach faculty. They feel these barriers, many students. Maybe they shouldn't, we could argue, but in practice, it's natural. And so every barrier that can be removed in the process is going to increase the number of students who apply.
Yes, absolutely.
I'm really curious with everything you do, multiple startups, everything at Berkeley and so forth. You probably don't have much time to unwind, but I'm curious, what do you do if you want to unwind, relax? What do you do?
Well, the one thing I like to do the most is hanging out with my 1-year-old. She's quite a delight and it's a lot of fun. But besides that, I like to run. I like to spend time with family. Maybe have some friend gathering and socialize. I like people in general. So I think people and maybe some workout would be my go-to activities. But my favorite person is my 1-year-old daughter.
Now, given you brought up your 1-year-old daughter, I'm going to try to ask one more question. As a parent, are there specific things that are really on your mind as you raise your daughter that you say, these are things I want to encourage her to do or expose her to? What's on your mind?
Yeah, good point. Obviously, I don't have a lot of parenting experience since she's my first and she's 1 year old, and I don't know at the end of the life if whatever I've done would have been successful. But one thing I do believe that has worked a lot for me and my brother, who's also an engineer, is this kind of approach that my mom had with us that I mentioned about reasoning. Try to tell them, think through this. Don't memorize. Don't just take people's opinions as granted, just reason through them. What do you think? Have critical thinking of the things you hear, of the things you see. Try to analyze and, I guess, put logic on a very important position in one's life. And a huge respect for reasoning and logic is something I would also try to instill in her.
Well, she might also challenge you then pretty quickly.
Hopefully. I'd love that.
Well, it'll be an interesting day to see when she wins her first logical argument against you.
These days, she schemes about getting her pacifier, which I have started reducing. And it was actually quite funny because she even tricked me the other day where she came to me hugged me and pointed that she wants up. And then she started pointing with her finger towards the kitchen. So I went there. She started to point to a counter, and I came closer. What does she want? And then there was this little doll. I went, you want the doll? But then I come closer to the doll, but then she fetches the pacifier next to the doll. And I remembered, oh man, yeah, she knows it's there. So it was the first, victory, against me.
Oh, wow. Very, very impressive. Raluca, this has been such a great conversation. Thanks so much for making the time.
Thanks for having me.